Previously, we learned about determinants, and in this lesson, we will learn to evaluate third-order determinants using expansion by minors. Now the question is, what is a minor in the context of determinants? Well, the minor is a determinant resulting from the deletion of the row and column containing that element. So for example, if I were to say, find the minor of the element 2, given this matrix. And when we say 2, we're going to refer to this one right here, this first 2. So to find the minor of that element 2, what I do is I delete the row and the column, and then notice the resulting matrix that's left over, the 0, 2, -3, -4. If I find the determinant of this, that will be the minor of element 2. So to find the determinant of this matrix, you multiply across 0 times -4, and then minus 2 times -3. And that gives you 0 minus -6, which is +6. Now let's try another example. If I were told to find the minor of the element -3, given the same matrix, well, I need to first delete the row and the column that contains the -3. So the row that contains -3 is right here. So we delete that, and the column that contains -3. And we're left with the 2, -1, 3, and 2. If I find the determinant of this matrix, that is the minor of the element -3. So to find the determinant of this matrix, I multiply across 2 times 2 minus 3 times -1, which gives me 4 minus -3, which will result in 7. Next, I'd like to show you how to find the determinant of a 3x3 matrix, but then we're going to relate this to minors at the end. So here's your matrix, A1, A2, A3, B1, B2, B3, and C1, C2, C3. Now to find the determinant, what I do is I begin by rewriting the first 2 columns. So I have here A1, A2, and A3, and then I have B1, B2, and B3. So then to find the determinant, what I do is I need to multiply across, so A3 times B2 times C1. So we have A3, B2, C1. Multiply across here, we got B3, C2, and A1. We're going to add these together, and I'll keep these in order by letter. So A1, and then we have B3, and then the C2. And then one more time with the C3, A2, and B1. So once again, keep them in order. Put the A first. We have A2, B1, and then C3. And then I need to multiply across the other way. A1, B2, and C3. So A1, B2, C3. And then B1 times C2 times A3. So A3, we'll do B1, and then C2. And then we'll do the C1, A2, B3. And we'll put the A first, A2, B3, and then C1. So what I do is I'm going to take this bottom row and subtract it by this top row right here. So what I have is going to be this. We have the entire top, the entire bottom, subtract the entire top. Right? And I just rearranged this, so we have in this bottom row right here the A1 first, so the A1 term first, and then the A2 term, then the A3 term. And then for the top one, we had the A3, then did the A2 term second, and the A1 term third. It doesn't really matter because what we're going to do now is we're going to group together the positive and the negative terms, where we're going to have this. So let me explain what we have. We have the A1 term right here, and then this negative A1 term we put over here. Okay, and then we have the A2 term, the negative A2 term. So this term right there is going to be right here. And then the A3 term right here we put right there. And then we put the A2 term, B3C1, this term over here. And then the minus A3B2C1 right there. So I rearranged this because what I'm going to do now is I'm going to group together in parentheses. And so looking here, these first two, and then these two, and then these two. What I'm going to do from here is I'm going to pull out a greatest common factor from each group that we have. So notice for the first set of parentheses, we have an A1 in common. So we pull an A1 out to get this first term. And then for the second set of parentheses, they both have a B1 in common. So I'm going to pull a B1 out, and I have this next term right here. And then, looking at the third parentheses, they all have a C1 in common. So I pull a C1 out, and I have this third term right there. Now take a moment and notice what we have in parentheses. It may not be very obvious to you, but if you were to look back at the original matrix, and you were to look at this portion right here. So if you were to look at the B2, the B3, the C2, and the C3, and you were to find the determinant of this, you have to multiply across to get B2, C3, B2, and then C3, and then you subtract, you multiply across again, B3 times C2. Notice that this right here is what I have in the parentheses for this first term. So what we have is actually a determinant of that matrix that I squared off from the original. I just erased all the ink to make it easier to see what's going on here, because looking at the next term, this A2 C3 minus A3 C2, if you were to look at this matrix, A2 A3, so these two, and then these two, and you were to find the determinant of that matrix, so the A2 A3 C2 C3, you find the determinant of that by multiplying across A2 times C3, and then multiply across this way, C2 times A3, or we could say A3 times C2. And then we subtract those two. And notice that's exactly what I have right here in the parentheses. I have the exact same thing. So the second one, the second term in parentheses, is actually another determinant. It's the determinant of that matrix. And then the same thing for A2 B3 minus A3 B2. If you were to look now at the A2 B2 A3 B3 and find the determinant of that matrix, A2 A3 B2 B3. The determinant of this matrix you find by multiplying across A3 times B2, and then we have A2 times B3, and we subtract A2 B3 minus A3 B2. That is the determinant of that matrix, which is what I have here in parentheses. So in parentheses, for each of these, I have a determinant. And the determinant is of those three matrices that I pointed out up here. These were the last two, and the first one I erased from the slide. But then, if we were to look at the original question to find the determinant of this 3x3 matrix, what we're actually doing when we find those determinants in the previous slide, those three determinants, they're actually the minors of A1, B1, and C1. So if I find the minor of A1, we eliminate this column and row. We're left with the B2, C2, B3, C3. So what I have is A1 times this determinant, and then I have B1 times this determinant of A2, A3, C2, C3. And then we have plus C1 times the minor of C1, which would be the determinant of A2, B2, A3, B3. So all I've done here is point out the fact that these matrices that we're taking determinants of, they are the minors of A1, B1, and C1. And then for simplicity, instead of writing out this matrix every time for each three of these, I can name them as A1, B1, and C1 with capital A's to name those matrices. So what I have is A1 lowercase times capital A1 minus lowercase b1 times capital B1 plus lower C1 times capital C1. And so remember, the lowercase letters are the elements, and then the capital letters are the determinants that we have about those different elements. So bottom line is, we can pick a row or we can pick a column, and we can find the determinant about that row or column by using the minors. So here's our first example where you actually have numbers put in here. So we can find the determinant by minors using any row or column. So here we're choosing to use the first row. And if we use the first row, right here, this first row, we take each element, the 2, the 0, and -2, and multiply by some determinant. So you take the 2, and you can eliminate the row and column that contain it. And so you take 2 times this determinant of this matrix right here, the 3, -1, 2, and -2. And we see that right here typed up. And then do the same thing with the next element, which is the 0. So then you have the 0, and then you eliminate the row and the column that contain the 0. You're left with the 2, -4, -1, and -2. All right, and then we'll explain the sign here in a minute. So you have this 0 times that determinant, and then do the same thing with the -2. So the -2, we can then eliminate the row and column that contain the -2. You're left with a 2, 3, -4, and 2. So you have -2 times that determinant. Now the signs are important, by the way. We didn't really discuss it too much previously, but the signs are important. So what we're doing here is we're actually alternating. So you look at the row number, okay? So we're dealing with the first row, so row 1, okay? If the row or the column that we're using to find the determinant is an odd number, we're going to start with the same sign. So we're going to keep the sign the same. So we're not changing anything here. But the next term, we're going to alternate. So the next term, we change the sign. So we change the sign for the second term, and then we have the same sign. We keep it the same for the third term. So in this case, it really doesn't matter because we have the 0 in the middle. So when you change the sign, instead of a plus, we would have like a -1 times the 0, which makes it a -0, which doesn't change because of the 0. But typically, it's going to make a difference. So that's going to be the case. So if it's an odd number of row or column, we keep this sign the same, then change, then keep the same. And if there's a bigger determinant with more terms, it's going to keep that same pattern. But if your row number or column number were an even number, let's say you're working with the row 2 or column 2, it would start off the other way. So instead of keeping the sign the same to begin with, we're going to change the sign of the first, and then we would keep the sign the same for the second term, then we change the sign for the third. All right, so if that was an even number of row or column, we'd have to do it in that manner. So that's the explanation of the signs. Now from here we can just try to figure this out, and we have to do the determinant of each of these. So looking at the red right here, the first determinant, we would multiply across to get -6, then minus 2 times -1, which is -2. -6 minus -2 makes a +2. So -6 plus 2 would be a -4. So what we have is 2 times -4 right there. And then the second one doesn't matter because of the 0, so that just is gone. And then this third determinant, we would do 2 times 2 minus 3 times -4. And so we have 4 minus -12, which gives you 16. So here we have a -2 times 16. So we have -8 minus 0, and then -2 times 16 is minus 32. So now we have -8 minus 32, which is a -40. So what this has done for us is we now have another method of finding the determinant, where now the determinant is -40. And this will be helpful because if you have a larger matrix, so instead of 3 by 3, maybe you had a 4 by 4 or 5 by 5. You can use the same method for those larger determinants. So for 3 by 3, we now we do now have the two different methods to calculate. And if we take a look at the same matrix that we just worked with, okay, we're going to verify that it does not matter which row or column we choose. All right, so here we are choosing to use the first column. So if we use the first column right here, we're going to prove that we will get the same determinant back out. All right, so if we use this column, you take the 2, then eliminate the row and column that are associated with it. It's kind of hard to see, but there's a line right here. And so you take the 2 and multiply by this, this matrix right here, this determinant of that matrix. So we have 2 times 3, -1, 2, -2. And then we can repeat that with the second element of the first column. So we take the 2, and then we eliminate the row and column that are associated with that. So we're left with 0, -2, 2, and -2. And we see that here in yellow. And we multiply that by the -2. Or sorry, that was a +2. All right, so +2. All right, and this minus, remember, is because we're changing the sign. So it goes from keeping the same to changing the sign. Then our third term would be the same. So we don't need to multiply by -1. So we now do the same thing with this -4. So we eliminate this row and column that are associated with the -4, and you're left with this matrix up here, 0, 3, -2, -1, and you take the determinant of that matrix. So we take -4 times that determinant. All right, so we have this, and then we can find the determinant of each of these matrices. So for the first one, we get 3 times -2 minus 2 times -1. So -6 minus -2 makes a plus. That would give you a -4. So we have 2 times -4. And then the second matrix, 0 times -2 minus 2 times -2. So -2 minus -4 would give you a +2. So we now have a -2 times that +2. And then here, the last part, we have a -4 times, and then the determinant we would multiply across, 0 times -1 minus 3 times -2, which would give you a +6. So notice we would get -8, this would be -4, this is -24, and when you put this all together, you're going to get a negative, and that would be 36. And actually be careful, made a small mistake up here. 0 times -2 is not -2, that's 0. So we have 0 plus 4, which gives you 4 right here. So -2 times 4 would be -8. -8 minus 8 minus 24 would give you, that would be -40. All right, so -40 should be your answer, which is the same that we had for finding the determinant about that first row instead of the first column. So we get the same determinant either way. And when you go through the steps, just be careful you're not making careless mistakes. As you see right here, is pretty easy to make. So it's a lot of steps, so be careful. Now let's find the determinant of the same matrix a third time. And the reason why is because I want to show you what happens if we choose an even number of column or row. So here we're going to work with column 2. And because column 2, the number 2, is an even number, the signs are going to be a little different. So using column 2, we're going to look right here. We're going to take this 0 multiplied by some determinant, and we can find that determinant by eliminating the column and row associated with the 0. So we have 0, and then times, and then the determinant of the matrix remaining, which is 2, -1, and then -4, -2. All right, so your first term is going to be like that. But because this number is even, we have the column 2, we change the sign of the first term by multiplying by -1. All right, and that's what we see right here typed up. And then we can repeat with the second term by looking at the second element of column 2, which is the 3. So we can eliminate the row and column connected with the 3, and you're left with a 2, -2, -4, and -2. And we see that typed up right here. And you take the 3 and multiply it by that determinant. So this side will stay the same. No need to change the sign because we're alternating. So we change the first, keep the second sign, and then we repeat one more time with this third element with the 2. So we can eliminate the column and row with the 2, and you're left with 2, 2, -2, -1. We see that typed up here in green. And then you multiply by the 2 that we were working with. So take the 2, the element, multiply it by that determinant. And notice our sign, we need to change it because we're alternating. So we start with changing the sign, then keeping the sign, and then here we change the sign. All right, so that's the difference. And then you can work through this and find the determinant of these 3 matrices. We would have -4 minus +4, which would give you 0. And then here we'd have 2 times -2 minus -4 times -2, which would give you -12. In the third one, we would have 2 times -1 minus 2 times -2, which would give you a +2. So what you have here would be 0 times 0, which would be 0, and then 3 times -12 is -36, -2 times 2 is -4, and -36 minus 4 is -40. So notice, with 3 different rows or columns, we get the same determinant back out. All right, so this method is a second method of finding the determinant, because we have the other method, remember, where you multiply across diagonally. We've seen that in a previous video, but here is an alternate method. So here's a 4x4 matrix, and we're going to do the same thing, finding the determinant about the first column. And once again, we can pick any row or any column. So picking the first column, I need to expand about each of the elements. And so we are going to start with the first element, the 2. And so we eliminate the 2, we're left with this big matrix, 3, -1, 5, 2, -2, 2, 4, 1, and 1. And then we look at the second element in the column. So looking at the 2 here, we're going to expand about the 2. So now we are left with the matrix 0, -2, -3, 2, -2, 2, 4, 1, 1. And you multiply by that element that we are expanding about. So multiply by the 2. By the way, notice the sign was positive here, then we have negative. The next one is going to be a positive, and then the fourth one would be a negative. So now we do the same thing for the third element. So looking now at the -4, we expand about -4. So we eliminate the row in the column that contain -4. We're left with the matrix 0, -2, -3, 3, -1, 5, and 4, 1, and 1. Then we're multiplying that determinant by that -4 that we are expanding about. And then we do the same thing now for the last element. So looking at the 0, we're going to expand about the 0. And so we eliminate the column and the row that contains 0. We're left with this matrix. So find the determinant of that matrix and then multiply by that 0 that we are expanding about. So now we are left with this expression where we have 4 different terms to figure out. And for sake of time, I'm not going to go through and find the determinant of each of these 3x3 matrices, because we have learned already 2 different ways on how to do that. We could multiply across 4 times -2 times 5, and 1 times 2 times, then you have the 3 up there. And you can do that that way, or you can do it by expanding by minors. But if you do it correctly, which we've already discussed how to do that, your answer should be 368. And you can double check and make sure you know how to solve each of these 3x3 matrices and see if you do get 368 back out. Now to wrap things up, here is an equation where we're trying to solve for x. And what we can do is we can use this idea of expanding by minors to find the solution for x. So what I want to do is I want to expand about the row or column that contain my unknown variable. So in this case, we're going to expand about the column. So looking at the column of 2, 0, and x, we're going to expand by minors looking at this column. And so we eliminate the row in the column with the 2 to begin, and we're left with a 3, -1, 2, -2. So we take 2, this element, times that by the resulting matrix, and then we do the same thing with the 0. So we expand about the 0, and we have 1, 2, 2, -2 left over. And then you multiply that determinant of that matrix by the 0 that we are expanding about. And then do the same thing with the third element. So with the x, we're going to eliminate the row and column containing the x. We're left with 1, 2, 3, -1. And then you multiply that by x by the element that we're expanding about. So now we have this equation, which we can then solve. So find the determinant of each of these matrices. 3 times -2 gives me -6, minus 2 times -2 is -2, -6 minus the -2 is -4. Same thing here, we get 1 times -2 is -2, 2 times 2 is 4, so we subtract and we get -6. Then for the third matrix, 1 times -1, I have -1, minus, then 3 times 2 gives me 6, so -1 minus 6 gives me -7. So I have 2 times -4 minus 0 times -6 plus x times -7, and that is all equal to 6. So we have -8 and then minus 0 and then minus 7x equals 6. We can solve this for x by adding 8 to both sides. We now have -7x equals 14, and then divide both sides by -7. Now we have x equals -2, and that is my solution. And that concludes our lesson for today. We will see you next time.